afternoon, everybody. And yeah, thank you to Tom and the team in the museum of having me here. And thank you all for being here. So I'm going to kick off this program by taking us back into prehistoric times, 1993. And that's when the original Jurassic Park movie was released. And so I was there in theaters as a very young kid watching this movie and was blown away by the spectacle. And what's been really neat is that I'm one of many paleontologists working today that's part of so-called Jurassic Park generation, because we were all inspired as kids watching this movie. And now we're doing the work as paleontologists. And what's even more beautiful is that the work that we're doing, the Jurassic Park generation, is continuing the legacy of providing new information and insights about dinosaurs so that filmmakers can have a better understanding how to depict these dinosaurs in movies, such as the Jurassic Park and Jurassic World franchise. But even before Jurassic Park, there was a close association between paleontology and cinema. So I want to take us even further back in time to early 1900s. So these are considered golden years for dinosaur paleontology, because a lot of institutions were funding expeditions to go out all over the world to discover the next new dinosaurs. This included our hometown institution, American Museum of Natural History, that went to, for example, the American West, and also faraway places like Mongolia, where Velociraptor was discovered. And another iconic dinosaur was also discovered in the earliest part of 1900s, so that includes the iconic T-Rex that's featured a lot in the Jurassic Park movies. And this is illustration from that first reconstruction of T-Rex. You can see combined aspects in terms of its posture. So it has this kind of semi-erect posture, not unlike the human depicted on the lower left there, as well as sort of traditional reptilian characteristic like the tail that's dragging on the ground. And so these types of reconstruction generally informed how the dinosaurs would be portrayed in movies at that time and for decades. So a nice example of that is the classic movie King Kong from 1933. And you can see the tail dragging towards the end. So this is how dinosaurs were generally depicted in movies, all the way up till Jurassic Park. So now, with that, we're going to go forward in time to the late 1900s. And this is a period of time in paleontology called the Dinosaur Renaissance. And it started with this fossil of a dinosaur called Deinonychus. The significance of this dinosaur was how the fossils were depicted and reconstructed. And so this is a figure from the publication that described Deinonychus, and you can see that it has a more sort of aerodynamic, active stance and posture, in contrast to sort of the erect and tail-dragging posture that the dinosaurs had before. It looks like a fierce, active predator. And so Jurassic Park, the original movie, came out on the heels of this dinosaur renaissance, how the dinosaurs were kind of rethought by paleontologists. In any case, Jurassic Park, the original movie, really set the gold standard for how dinosaurs should be depicted, because it was based on the latest science at that time. So, what happened after Jurassic Park? Well, actually, only a few years after the original movie came out, in 1996, you have this remarkable fossil found in China. So it's Sinosauropteryx, and not only is the skeletal material really well preserved, we have an entire animal, but if you look at those dark impressions, those are actually impressions of feathers, or at least primitive forms of feathers. So this fossil represented the first direct evidence of feathers associated with dinosaurs. And after that, we have tons of fossils being found, especially from China, of these beautiful fossils with feather impressions. So we have Microraptor and Anchiornis. And these are dinosaurs that are very closely related to Velociraptor. So now we know that Velociraptor and its kins had these fully fledged feathers covering their bodies. And not only that, about 15 years ago, there was a pair of high-profile research studies that looked even more closely at these feather impressions And what they found are these subcellular structures called melanosomes. And these are organelles within the cells that produce color. And by using scanning electron microscopy, they could look at not the actual organelles themselves, because they weren't preserved, but the shapes left by those organelles. And there were different shaped melanosomes being preserved. And if you look at the shape of melanosomes in modern birds, you can see that the different shapes correspond to different colors, all the way from rust-colored feathers to black and even iridescent colors. So you can use this technology to actually reconstruct the dinosaurs in their true colors as they were when they were alive, which I think is remarkable. Right? So we have Microraptor, which had a dark and iridescent feathers, kind of like crows, and Anchiornis, which had sort of zebra-like pattern, not only on its forewings, but also the wings on its hind limbs. And it had this really cool rust-colored mohawk on its head as well. Also, we have Sinosauropteryx, which was also reconstructed using the same kind of technology, and we now know that its tails have these stripes, kind of like ringtail lemurs. So as a kid growing up, reading through dinosaur encyclopedias, we were told that, hey, you can never know the true colors of dinosaurs unless someone invents a time machine. But actually you can now, which is just unbelievable. All right, so going back to the movies. So how have these recent discoveries changed or not changed how the dinosaurs are depicted in later Jurassic Park movies? So let's look at the evolution of how raptors have been portrayed. And it's a nice example because raptors have been featured across the entire franchise. The original raptors in the movie, they didn't have feathers, but that's fair because the fossil that I showed you, Sinosauropteryx, haven't been discovered yet. But let's skip over to the third Jurassic movie, which was released in 2001, so well after we've known that Velociraptor and its kins have had feathers. So this picture is a little blurry, so let's enhance, and enhance once more. And we can see that the filmmakers did acknowledge the presence of feathers, or very rudimentary structures, and also on kind of very localized area, just the back of the head. So the filmmakers, they probably argued, hey, we at least acknowledge that the feathers exist, but did not make any of the paleontologists happy. And then let's skip over to Jurassic World, which came out quite a few years after this movie. And unfortunately, they regressed back. So they don't even have these rudimentary feather structures. And I know there's sort of a narrative explanation in the movie, but it also didn't make any paleontologists happy, right, on social media. So let's take a look at at least the latest movies in terms of the one released before the next one gets released soon, which is Jurassic World Dominion from a few years ago. And did the filmmakers listen to the complaints of the paleontologists? Let's find out. But enough footage to see what they've done. So yes, for the first time we have in a Jurassic Park movie, we have fully feathered raptors, which is great. But this is one of those one important step forward but two steps backward kind of a situation. Because Pyroraptor, which is the raptor being depicted there, there's absolutely no evidence that they survived in Arctic conditions, nor is there any evidence that they were great swimmers. So it still made a lot of the paleontologists quite angry. But they were happy enough that feathers were at least fully acknowledged. So I've shown you evolution of how the raptors have been depicted, but how about another iconic dinosaur featured in these movies, T-Rex? And what I'm going to show you now is the latest depiction of T-Rex, and it's featured in a show called Prehistoric, which is a wonderful series based on a lot of the scientific evidence. So looking at it quickly, you think, oh, T-Rex didn't have feathers, but hopefully the resolution is good enough that at least on its back you can see this kind of thin layer of sort of tufts of maybe a rudimentary feather. There isn't actually a direct evidence that T-Rex, completely lacked feathers or that they had feathers. And this is probably because T-Rex live in an environment where feathers wouldn't get readily fossilized and preserved. But why do paleontologists think they might have had feathers? So they have good reasons. So we go back to fossils being found from China, and we know that the ancestors of T-Rex had feathers. So fossils have been found with feather impressions, including this one, which is a pretty big animal. And we can have sort of Dennis show us the relative size of this. So not as big as T-Rex, but we have a large body cousin of T-Rex with a bunch of feathers. So that's why we think, or paleontologists think that T-Rex might have had some feathers. So we'll find out more definitively, hopefully, in the near future. And then I'm going to conclude my talk by talking about something that's also related to how dinosaurs are portrayed in media. So we have appearance, but now behavior is a big component of that as well. And what drives their behavior is, of course, their brains. And that's what I study as a paleontologist and researcher. So why do we care about this, besides being fun and fills my curiosity? Well, another reason is because modern birds, which are living descendants of dinosaurs, are pretty smart. So this is a crow performing a bunch of pretty sophisticated behaviors, and they're solving puzzles. And so this is obviously driven by their brain. And so if someone calls you, bird brain, colloquially that's not a nice thing to say, but you can tell them back that scientifically it's a compliment, right? And so we want to understand how birds attained their smart brains. And to do that, we need to go back to looking at their dinosaurian ancestors. But the issue is brain tissue doesn't get fossilized. So how do we actually look at their brains? Well, so we use a technology called X-ray-based CT scanner, and this allows us to peer into the internal structures of fossils, including the skull of a dinosaur from Mongolia, and you can digitally fill in the space that used to hold the brain. So that's what's rotating right now. And this gives us a good representation of what their brain looked like. And we can use this technology along the species along the dinosaur to bird transition. And so what we found out is that both dinosaurs and the earliest birds living together with dinosaurs, they had underdeveloped brains in some of the brain regions compared to modern birds, but they were actually quite developed compared to other reptiles and more primitive dinosaurs. And so dinosaurs closely related to birds like Velociraptor probably did show some sophisticated behaviors, at least to some extent, with how they're depicted in the Jurassic Park movies. But we go back to, again, this iconic other dinosaur, T-Rex. All right, so Dr. Grant, he said T-Rex wouldn't be able to see if we don't move. Is that correct? Well, so we actually have brain reconstructions from the T-Rex, and if we compare that with birds more closely related birds, and also modern birds themselves, we see that the optic lobe, which is responsible for vision, is actually kind of flatter and less developed than some of these other animals. So it's true that they might have not had as keen a vision as, for example, modern birds or even Velociraptor. But they're not underdeveloped compared to other reptiles like alligators and lizards and snakes that see just fine. So there's no reason to think that they're blind, or at least blind when you're not in motion. Also, on top of that, the olfactory tract, which is responsible for sense of smell, is proportionately larger in T-Rex. So this at least suggests that they have very keen sense of smell. So what does this tell us? Well, if you do run into a live T-Rex, I highly recommend you do one thing.
Run!
Thank you. Yeah, so the question was, how does the olfactory tract and lobe of T-Rex compare with dogs? So, yeah, so dogs obviously are known for having, very keen sense of smell. With T-Rex, I told you that we use this technology to look at the space that used to hold the brain and neuronal structures. How much of that space is filled in by the actual neuronal tissue? So there might be, a gap between the actual neuronal tissue and the compartment of the skull that used to hold the brain. So we can only kind of compare it to more closely related species. So like within dinosaurs, or comparing it to birds. Comparing it across mammals, it's a little bit more difficult to do. So this is a way of me saying that it's like kind of difficult to make a direct comparison. My guess is mammals in general have evolved with a strong selection for sense of smell. So I would bet that dogs and other mammals do have probably had keener sense of smell than what dinosaurs did. But even then, I think just comparing within dinosaurs and even especially birds, which have very small olfactory lobe and tracts, T-Rex were able to smell, which could be related to them being able to smell, carcasses if they were scavenging, for example. Do we have time for one more question?
Yes, we do.
Yes? Okay, go ahead.
Of all the dinosaurs depicted in the films, which is the most egregiously off base? And is the Dilophosaurus spitting venom in that top 5?
Oh, it's definitely in top 5. Yeah, actually, I was going to pick that one as number 1. Just to review, Dilophosaurus is the one where the venom spitting in the original movie. Definitely didn't have the frills. And it definitely didn't spit venom either. So I would say that's probably the most inaccurate depiction of dinosaurs. Other than that, people ask me sort of on a related question about if I'm bothered as a paleontologist, if these movies are if there's some inaccuracies. And my answer to that is, hey, if it inspires at least one person to become a paleontologist, or at least be interested in pursuing science, then I think it's doing its job. So I'm less bothered than some of my colleagues.